Sensors Connection, Modbus RTU, Serial. In this video, we will demonstrate how to connect the ePowerControl to sensors via a serial connection. The video is divided into 5 sections. Required materials: connecting the sensors to the controller, configuring the LAN port, adding the sensors to eConf, testing communication with the sensors. Part 1. Required materials. Elm's device and the sensors are communicating in Modbus RTU. For this, we will need Elm's device is connected to the switch via LAN port 1. Shielded twisted pair cable. Termination resistors with impedance matching the communication cable, typically 120 ohms. Flathead screwdriver, bootlace ferrules, wire stripper, crimping tool, laptop, RJ45 to RJ45 Ethernet cable, USB to RJ45 adapter if your laptop does not have a LAN port. Part 2. Connecting the sensor to the controller. Before connecting the sensor, make sure to set a unique slave ID on the RS485 network, 1 to 247. Configure the baud rate. Set the parity. Adjust the stop bit. The sensor can be connected to one of the serial ports of Elm device. Multiple devices can be connected to the same port. The serial ports are located at the bottom of Elm device. Use a flathead screwdriver to unscrew terminal connectors, 1 or 2 for easier cable wiring. Gently pull on the terminal block to remove it. Grab the twisted pair cable and identify the color code based on the manufacturer's manual. In our case, we will use the brown wire for data B, positive, the white wire for data B, negative, the yellow wire for ground. Try to organize the wires for better handling. Use the wire stripper to remove the insulation from the wires. It is recommended to use bootlace ferrules as they provide a more reliable and secure connection by preventing fraying and ensuring proper contact. Try to organize the wires for better handling. Connect the shielded wire to the ground wire by twisting them together, only on the controller's side. Ensure you fit bootlace ferrules on the ends of the positive and negative wires. Grab the terminal block and connect the brown at the pin 3 data B, positive, the white at the pin 4 data B, negative. Take the terminal resistor and place it between pins 3 and 4. After properly connecting all the cables, reconnect the terminal block to Elm's device. Once the terminal block is properly inserted in place, use a flathead screwdriver to tighten the end screws of the block. To connect multiple devices to the same serial port, follow the steps and diagrams shown below. Note that some devices may not have ground ports. In such cases, only connect the data pins as described. It is highly recommended to use surge protection to prevent issues with the communication ports. Part 3. Configuring the LAN port. Connect your laptop to the LAN port 2 of Elm's device. Access the settings from your laptop. Go to Network and Internet Settings. Go to Change Adapter Settings. Right-click on connection to the local network. Select Properties. Click on Internet Protocol version 4, TCP/IPv4. Select Properties. Select Obtain an IP address automatically to enable automatic IP address allocation, or select Use the following IP address for manual IP address assignment and enter the settings as shown in the next window. A small TCP/IP window will appear. Click on Yes. Click on OK to save configuration. Open your preferred browser and log into eConf by entering the following IP address: 192.168.4.127. Enter your password to log into eConf and click Sign In to connect. On the left sidebar, click on Network. Click on Configure a new connection. Then, in the interface menu, choose Serial 1. In this list, select the serial where you physically connected the sensor. Select the appropriate operational network communication mode. Select the appropriate baud rate, which must be identical to the one set on the sensor. Select the appropriate parity, which must be identical to the one set on the sensor. Select the appropriate byte size, which must be identical to the one set on the sensor. Select the appropriate stop bits. Click on OK to save the settings. Part 4. Adding the sensor to eConf. In the column specific to the Serial 1 connection, click on Add Device, enter the device name, select the sensor's vendor from the drop-down list. Select the reference of the sensor from the vendor-specific drop-down list. Select the Modbus RTU protocol for communication between ELM's device and the sensor. Enter the slave ID assigned to the sensor. Configure the response timeout and byte timeout. The interframe delay is set to 10 by default. Click on OK to save the settings. Part 5. Testing the communication with the sensor. To test the connection between ELM's device and the sensor, first check the communication status by clicking on the three dots next to the name of the sensor you added. Click on Test. If your sensor is not connected, this window will appear with the Not Connected red indicator. Follow the provided troubleshooting instructions to help resolve the communication issues. Another way to test all devices connected to the same port in a daisy chain is by clicking the refresh icon next to the configured port Serial 1. This will display the status of those devices. eConf provides a few troubleshooting instructions to help resolve communication issues. Once all these steps are completed, communication should be established. As a second step of connection testing, let's verify the data acquisition. Navigate to All Devices from the left sidebar. Click on the recently added sensor. The page displays all the data that the controller will read from the sensor. Cross-check all the read values with those displayed on the sensor itself, if applicable. The controller must receive accurate data to prevent issues in control scenarios and set points. Please feel free to contact ELM's support or your sales managers. Eager to see you in our next training session.